Hey TechKnowStuds! With IPv4 addresses, we identify the network bits using either a subnet mask or a CIDR notation. So what we have to do is do the same thing with IPv6, but we use what's called a prefix length. It operates very similarly to the CIDR notation. So in this video, let's get into the prefix length and how it identifies significant bits. The RFCs that define IPv6 break up an IPv6 address into smaller components. For the purpose of this course, let's talk about three of those components. First of all, we have the global routing prefix. The global routing prefix is the first 48 bits. And this is usually what's given to the ISP, or really what the ISP gives to you. Then we have this second section right here, which is the subnet identifier. So this identifies the subnet. And then the last portion of this is the interface ID. So this defines the actual interface or the actual node that's on your network. And so these are the host portion. So if we're talking IPv4 language, this is the host portion, and this is what we have to subnet, and then this is what's given to us from the ISP. So a prefix length does identify the network bits. If you were to assign an IP address to a machine, so let's say we assign this IP address to the machine, then it is given a /64, meaning that the first 64 bits are the network portion of this. Well, we can just identify the network side then just by dropping off the interface ID here, and we end up with this. Or we could even condense this down by just removing this :0000, and that is the network address for this. And it's /64 because the first 64 bits identifies the network portion of this. But there are also other cases that we use the prefix length, similar to actually with IPv6 and the CIDR notation, to identify sections of this address. For instance, let's say you were to be assigned a /48 address from the ISP, then this portion right here is what you're given. The first 48 bits is defined by the internet service provider, and that's what you have to work with. And then you have everything at the end here from a /48 to a /64 that you have to actually work with for subnetting purposes, to identify different subnets part of this. So essentially this is the subnet. This is how we do the subnetting using this hextet right here. So just realize that when we say /48 here, your network is still going to end up being a /64. We're just identifying which bits are significant with this prefix. So let's take a little more granular look at this. We're going to take a look at prefixes from a binary standpoint. When I look at the binary numbers, the ones and zeros that are made up of this is this first row right here. This is representing the address that we saw in our last slide. So I just broke it down into the nibbles. So these are the same numbers. The second row is the same numbers, except for these are just written out into its nibbles, broken down in its nibbles. And then those nibbles are converted to that hexadecimal number, which we're used to seeing now with IPv4 addresses. So prefixes do identify the network bits. And in this case, it'd be just the /64. I don't have the last 64 bits showing here just because I didn't have enough space. But imagine here that it continues on. There's another 64 bits on here, and those 64 bits identify the interface. So that is going to be the network portion of this. But often your internet service provider assigns you these bits right here, and you don't have much option with it. So they're going to say that it's a /48. The /48 identifies those as being significant bits, even though your networks are going to end up being a /64. That just means that each one of these bits can represent a different network. So we have 16 bits there. So with 16 bits there, we have 65,536 options, which means that there's 65. We can break this down into 65,536 different subnets. So we got a lot of mobility and a lot of ways that we can arrange this. But realize we're not always going to see a /48. In fact, we're going to identify some ranges here, and we may see something like a /3, which means that we draw the line right here. So that's where we're going to draw the line. It just means those are the significant bits to identify the range. Or maybe we see a /10. That means that we're going to, here's 4, here's another 4, so that's 8, and there's 10. So we're going to draw the line right here. And so then those are the significant bits of that range right here. Or maybe we see a /16 because that's the first 16 bits, or maybe we see a /32 or a /48 or a common. Usually we break things down into nibbles, so maybe you're breaking down your network into these portions right here, and you're going to see a /52, a /56, and a /60. And a /64. So really, this is just to identify portions of the network and be able to divvy this up or hand this out to different sections of the network. But your end goal of all of your networks are pretty much going to be a /64 when it comes to assigning IP addresses within your network.